Welcome to The Explainer. Today, we are diving into an absolutely monumental shift in API architecture. Honestly, it's a change that's going to fundamentally rewire how AI developers build and scale systems. For years, we've all just kind of accepted this massive structural problem in how we request data. But finally, there's an actual protocol-level solution. So if you're building agents, gateways, or really any data-heavy APIs, you're going to want to pay close attention to this.
So here is the million-dollar question. How do we ask an API for complex data without flat-out lying to our own infrastructure? It's wild to think about, but we've all been committing this 16-year-old API sin just to make complex searches work. We've literally been trapped in this weird design compromise, tricking our servers, our caches, and our proxies just to send a basic read-only search that happens to have a large payload. But thankfully, that era is coming to an end.
All right, let's quickly hit today's roadmap. We're covering the read-only post hack, why AI agents suffer, the HTTP query solution, 4 big operational wins, and finally, adoption and potential gotchas. Let's get right into it.
Section 1. The read-only post hack. Okay, to really grasp the problem, we've got to look at the classic dilemma between get and post. When you're running a search endpoint, you are just reading data, right? So architecturally, that should absolutely be a GET request. GET is perfectly safe, it's idempotent, but what happens when your filter payload, like, say, deeply nested JSON, a huge vector array, or a massive GraphQL query, just will not fit in a standard URL string? It breaks. So what's our workaround? We use post. Post has zero trouble carrying massive data bodies, but the massive trade-off here is that post is structurally unsafe. It explicitly tells the network that it's changing state or mutating data.
And the downstream impact of that compromise is just huge. By using post for a simple read-only search, we are literally lying to our infrastructure. Because the method says post, proxies get scared to safely retry it if a connection drops. Caches, they automatically skip it because they think you're writing to a database. Literally anything on your network that reads the word post ends up treating your totally harmless search like a destructive write operation. Now, for human-driven apps, we've kind of just gritted our teeth and tolerated this, but the game has completely changed now.
Section 2. Why AI agents suffer.
So, unlike human users who might mash a search button once or twice, AI agents are basically high-volume retry machines. They loop, they hit timeouts, they get partial responses, and they are constantly firing off near-identical retrievals dozens of times per task. And when an agent loses a post response, retrying it becomes a total gamble. Like, did the server already execute that state change? Who knows? To stop things from double firing, developers are forced to hand-build these incredibly complex idempotency keys. It creates this super brittle environment where ambiguous post requests lead to silent breakages and just massive inefficiencies. It's an absolute reliability nightmare.
Section 3. The HTTP query solution.
Well, fast forward to June 2026. The HTTP standard finally received its first major architectural update, its first new general-purpose method since Patch was introduced way back in 2010. This is a massive fundamental upgrade to the very protocol that powers the web. Enter RFC 10008, the new query method. Basically, query asks a target resource to process a request body as a query and return those results safely and idempotently. It perfectly marries the massive payload capacity of post with those strict, rock-solid safety guarantees of GET. Plus, it's totally format agnostic. Your body can be JSON, SQL, XML, whatever you need. It is exactly the missing puzzle piece we've been waiting for.
It really all boils down to this dynamic. GET tells the truth about being safe, but complex payloads just don't fit. Post fits the payload easily, but flat-out lies about its intent by claiming it's a state change. Query is that perfect sweet spot. The payload fits neatly right in the body, and it tells the complete honest truth. It's declared safe and idempotent right at the protocol layer. No more lying to the network.
And here is where query genuinely feels like magic in practice. It enables this incredible one-round-trip caching trick. Step 1. You send your query with your massive complex JSON payload. Step 2. The server runs that expensive read, returns your data, but crucially it also hands back a specific location URI. Step 3. The next time your agent needs that exact same data, it skips sending the heavy payload entirely. It just uses a super cheap conditional GET request on that URI. If the data hasn't changed, the server just returns a 304 not modified. Boom! You have just collapsed an incredibly expensive structured read into a lightning-fast, highly cacheable response.
Section 4. 4 big agent wins.
These 4 properties map beautifully onto those exact failure modes we were just talking about. First up, safe retries. Because query is idempotent by definition, an agent looping or retrying a lost request is always structurally correct. You don't have to hack together idempotency keys for reads anymore.
Second, read and write gateway enforcement, which is an absolute game changer for security. Third, caching radically cuts down on redundant RAG retrieval loops. And fourth, fat filters finally fit natively. All those massive vector queries and GraphQL selections, they're natively supported as reads.
Let's zoom in on that gateway enforcement for a second, because the security advantage here is profound. Look, the proven way to run AI agents safely is to strictly limit what they can do. But back when reads and writes were both hiding behind post requests, gateways couldn't tell them apart. Now, security teams can mechanically enforce permissions. Your gateway can freely allow, cache, and rate limit a query, knowing with absolute certainty it's just reading data. Meanwhile, it can strictly gate, audit, and require human approval for actual state changes like post, put, or delete. We are finally moving the read-write split from an API documentation suggestion into strict protocol-level enforcement.
And we absolutely have to talk about the financial impact, because this will dramatically shrink your infrastructure bill. Remember, retrieval cost sits upstream of token cost. Fewer backend hits literally means fewer tokens spent. Agentic retrieval loops constantly repeat themselves during multi-hop plans and self-correction. But because query allows all those redundant requests to be properly cached at the edge or proxy layer, you drastically reduce your backend hits. When your agent pulls from a cache instead of doing a heavy, fresh database read, you are saving a small fortune on unnecessary LLM tokens rereading the exact same context.
Section 5. Adoption and Potential Gotchas.
Okay, first, a huge warning here. In HTTP terms, safe just means the request doesn't alter database state. It absolutely does not mean zero cost to your infrastructure. An AI agent stuck in an endless loop firing massive query requests can and will completely flatten your backend databases if you aren't careful. You absolutely must treat query as its own unique class and apply dedicated rate limiting to protect your replicas.
The second gotcha to watch out for is cache poisoning. The spec requires the cache key to actually include the request body, because obviously a different body means a completely different search. But if your cache normalizes the JSON body differently than your backend server does, like reordering keys or stripping whitespace, it might accidentally serve a false positive hit. A human might see a weird search result and refresh, but an agent will just silently ingest the wrong context and poison its own reasoning. You should only cache Qmery if your body normalization is absolutely perfectly aligned.
So what's the adoption timeline looking like? Right now, Edge support is landing super early. Heavy hitters like Cloudflare and Akamai actually co-authored the spec. In the short term, while web frameworks catch up, you can write a really simple client-side fallback. Try query, and if the server spits back a 405 method not allowed, just gracefully fall back to post. Long-term, frameworks and browsers are going to support this natively, but the best advice? Start adopting query inside your own perimeter today. Get it working between your agents, your gateways, and your internal microservices, way ahead of the open web.
Which leaves us with one final thought. Are you going to start auditing your read-only post endpoints today? Or are you going to sit back and let your infrastructure catch up first? Look, if you're building agents or managing heavy API infrastructure, query isn't just a fun new tool. It is a massive authorization primitive and a huge performance multiplier you really can't afford to ignore. Start mapping out your internal migrations, get the semantics right, but hey, maybe don't needlessly break all your public-facing APIs this quarter while client support is still catching up. Thanks so much for joining me on this explainer, and happy building.